Hello, everybody. Thanks for tuning in again today. We have some good information today for homeowners and what to look out for in some of your electrical problems that you may be encountering in your home. If you're getting a home renovated, if you're getting a new home built, what we're going to cover today is the top 9 things that we typically see as defects in a home. And some of these can be relatively easy fixes. Some of these are hard to fix, and they're not going to be fixed without full-scale renovation. But just some good information that's going to give you confidence in the home you're buying, the home you live in, and so forth. So let's get started today. So electrical defect number 1. First of all, I've got these from a list on average of things that we see on home inspections over the last 20 years. And so these are some, maybe not in order of importance or maybe even frequency, but among the top 9, these are some of the things we see. It's certainly not exhaustive. There's other things you see that aren't on this list, but some of the most common things we see are on this list. So number 1, ungrounded 3-hole receptacles. Some call them outlets, some call them receptacles. This is what I'm talking about. You got 3 holes up here, you got 3 holes down here. And what that means, when you see this in a wall, this is what you're typically going to see in a new house. Well, you better see this in a new house, but the most common outlet these days is one of these. And so you've got the neutral, you've got the hot, and you got the ground. When you see a 3-hole receptacle, you have the assumption that this is grounded. All right. And so when an inspector goes through and he uses his tester to test this and it comes back as ungrounded, that means we have a problem with the ground part of it. Now, what's the problem? Well, the problem could be as simple as something's loose. The screw on the bottom that the ground wire goes to, sometimes the wire becomes loose and that's all that needs adjusted. Sometimes somebody didn't attach it at all. And then in the worst case scenario, you don't have a ground wire. For example, if you have older wiring in your house, this is all cloth covered wiring, and we got the black wire is the hot, the white wire is the neutral, but notice what else? We don't have a ground wire, all right? You may have this kind of wiring in your house, and if you have this kind of receptacle, you're going to have an ungrounded receptacle, all right? And that's why it's going to show up that way. Whereas modern wiring is going to have a hot wire, a neutral wire, and a ground wire. And that's what should be connected to this that will show with the tester that it's grounded properly. So if you don't have that, you're going to have an ungrounded outlet, and that's considered an electrical defect. It's more of a defect for the appliances that it's plugged into than for the person living there. All right. For example, if you have one of those nice fancy new refrigerators that have the screen on them and they talk to you and have TVs on them and so forth. Many of those are not going to be covered under warranty if they're not plugged into a grounded outlet or a grounded circuit. And so you want to make sure, especially with some of the appliances in your house, that you have that. And we'll talk a little bit more about that in just a second. But anyways, what's the fix if you have an ungrounded outlet? We're going to use outlet just because it's a shorter word, and receptacle is used in some areas and not others. So we're going to go with outlet. So let's say there's no ground. All right. You got a couple of options electrically to improve it. All right. Number 1, you can install a GFCI outlet or a breaker for that system. Now that won't ground it. It does add a little bit of protection, shock protection, and upgrades it to a degree, but it still doesn't ground it. Number 2, you can run a separate ground wire through the circuit. Now, this is feasibly very hard. It's not very feasible, I should say, because you're going to have to go through the wall, through the joist to get it through the whole circuit. Number 3, you can rewire the whole house. If all you have is this older type wiring and you have these kind of receptacles or outlets, you're going to have to do one or the other. Okay? You can rewire, which is the most costly. It will upgrade all your wiring in the house. All right. Another option for you is replace these with 2-hole receptacles. They would just have the hot and the neutral, and they wouldn't be grounded. There are many things that you plug in that just has a 2-prong plug on it, and you don't need a ground wire. All right. So that's considered acceptable electrically. It's just what it was up into the 50s, even to the 60s, where they ran that type of wiring most commonly. All right. So those are some of your options. Here's probably the best option overall. Let's say you bought a house in the 50s and your outlets are ungrounded, and you buy these new TVs. I've seen recently you can now buy 100-inch TVs to put on your wall. Well, obviously a big TV, a computer, even a hairdryer, they need a grounded plug, right? Or a grounded outlet. I'm using all kinds of vernacular today on what these are called. But what we have found is a common sense approach, a reasonable way to fix this without rewiring the whole house, is find that spot on the wall where you're going to put this appliance, your refrigerator, your TV, your computer, whatever, and let's run a new wire from the electrical panel just to that outlet. Now, it doesn't ground the entire circuit, but it does give you what you need for that particular appliance or electronic or whatever. I don't know if I've ever seen a home where every outlet in the home is being used. And that's rare if they are. You might have 4 in a room and you're using 1 or 2 of them. So find the ones that would be used most often, run a separate wire that can fish it up the wall, that can come down the wall, but they don't have to tear apart the wall to go through it to get to the other ones on the circuit. So that's one option for ungrounded outlets. We started you off with one that's very common, but it's not the easiest in the world to fix. It just isn't. So if you have that situation in your house, if you want to upgrade that, contact an electrician to get the best option for you on that. Okay, number 2, reversed polarity. Reversed polarity simply means they've wired the outlet in reverse. Back to our little outlet here. On one side, we have silver screws. On the other side, we have gold screws. And that is not just random coloring, all right? Silver screws are on the side with the larger slot, and that's what the neutral wire should go to. In our previous example here, the white wire would go to the silver. And the black, the hot wire, would go to the gold side, all right? And so if that is done incorrectly, it's going to be reversed. It's going to show up on your tester as wired in reverse. Reversed polarity is what we call that. And that's more of a potential hazard for homeowners, especially in consideration of something like a lamp. If the lamp is plugged into one of these that is reversed, then when you shut the power off, there still can be current running through that outlet. And so your lamp would still have current. You change the bulb, you're touching the base, the socket in the lamp and the base of the bulb at the same time. You could potentially get shocked with that, and it can be a hazard to you. So make sure if you have reversed polarity in your outlets that gets fixed pronto. The good news is that's a pretty simple fix. You just have to, in most cases, reverse the wires and obviously shut the power off first, reverse the wires, and then it should be fixed for you. So again, these things are not recommended for a homeowner that doesn't have the skills to do this safely. So if you don't try to be a hero. Hire an electrician that can get this done pretty quickly for you at not much cost. All right. Number 3 is a pretty big one. And we're talking about knob and tube wiring. Knob and tube wiring gets its name from, pull our little show and tell item out here. This is some old knob and tube wiring, and we got the ceramic knobs. Obviously these are broken, but it would run on joists or up on the attic rafters or in the basement or whatever on these ceramic insulators. And if it goes through something like through a joist, you'd have a tube that looks just like this with a hole through the center of it. All right, knob and tube. And essentially what you have here is I've just showed you, this is older cloth cover, but you got the hot and you got the neutral. Well, you got the same on here, only they're separated. All right. Updated, this is considered updated, compared to knob and tube, but you had the 2 wires inside of the sheathing, all right? They didn't on knob and tube. They ran them separately. And one of the reasons they did that is for heat dissipation. So when these get current going through them, they get warm. You want that heat to be able to dissipate so it doesn't build up and potentially cause a fire. So these were used into the 30s. So if you have a home with knob and tube wiring, you can be sure that this is probably at least 80 or 90 years old. That seems kind of old for wiring, for anything, right? Certainly vehicles don't last that long. A lot of people don't last that long. So it's still considered in some circles to be acceptable if the knob and tube wiring has not been damaged, if it has not been altered, if it hasn't been spliced into, if mice haven't chewed off the insulation, and so forth. Now, here's what's happened. Back in the 20s and 30s, when it was real popular, not a lot of houses were insulated, or at least not very well. And so then you had this writing right on top of the attic, the floor joists in the attic, and then they come along and they try to get more energy efficient, and they cover all of this with insulation. All right. Now what happens? Now that heat can't dissipate like it needs to. And the other thing, and it can potentially cause a fire. The other thing that can happen is now that you have insulation packed all around it, you get critters that burrow in that insulation, and they love that little home. All right. And so they're going to be chewing on that stuff because they're attracted to that, to the warmth, to the current. And so several things can go wrong when you have knob and tube. And my recommendation is that if you have knob and tube in your house, that you get it replaced. All right. There's really no other option. It's not like ungrounded outlets where you can run it to a certain area or whatever, but replacement is really the only way to do this. I did this a number of years ago with a rental house that I bought. I saw that it had knob and tube. I hired an electrical company to replace it all, just so I had peace of mind that my family living there and their friends would not be at risk any more than needed. So there's no cheap way to do it. A single level home with a basement is probably your best cost rating as far as it's easy to get to everything. If you have a slab, if you have a 2-story house, it's going to cost more because it's harder to get to. It's harder to run down the walls and so forth. So knob and tube wiring, not recommended. Another thing to make sure of is if you're buying a house with this especially, make sure your insurance company is going to cover the home. Many times they won't if they know that you have knob and tube wiring, and obviously that's a big problem. So number 4, double tapped breakers. Now a breaker is that overcurrent device product in your breaker panel. It could be a fuse too. Some of the older houses still have fuses. But what this means when they're double tapped, some call them double posted. Basically, you've got 2 wires going into one screw. You have a screw on the side or the back of that breaker. And if you run 2 wires to it, it's considered doubled up. I've seen 3. We've even seen 4. Okay. And that is not good. And here's why. It's not necessarily the overloading of the circuit, but it's more about that breaker was designed, that screw was designed to screw tightly onto one wire. It was engineered that way. And when you put 2 on there, you put 3 on there, maybe you put the wrong size in there along with the other ones, you're going to have something that's loose. And loose wires create heat or resistance, and then heat, and then potentially fires. Now, do we ever see a problem with this? Honestly, we can't say that we see a problem with it, but it's also a very simple fix. And just because we don't see it during the inspection doesn't mean there isn't a problem with it. We don't do exhaustive testing on the entire circuit and so forth. So you can add breakers, you can combine circuits. There's various ways to approach it. Worst case, if the panel's way overloaded, maybe you can add a sub panel onto that so that you have more spaces for breakers. So double tap breaker is a very common defect that we see, but also quite easy to fix. So number 5, oversized breakers. And this is one, typically it can happen a couple of different ways, multiple ways, but 2 most common ways we see is on the air conditioner. Maybe an older air conditioner drew more amperage, and so they put in a newer modern air conditioner that's more efficient. They run a smaller wire for it, but they leave the same breaker in the panel. And so you might have a 50 amp breaker protecting a 20 amp or even a 30 amp wire coming from the air conditioner. All right. The air conditioner has a rating on it as to what the maximum overcurrent device is. And that's for protection in case it's running too hard or clicks off for whatever reason. If the breaker's too big, it can damage the air conditioner or any other circuit that it's on. It can allow the wire to overheat before the breaker clicks off, which would, again, cause resistance, cause overheating, cause fire. So oversized breakers are a pretty serious deal, and you'll see melted wires sometimes in those, and those just need to be replaced. Fortunately, it's a simple fix. Put the right size breaker in, and that's about all that needs done by a professional in that case. All right, number 6, improper splices. Now, frequently this is done in areas that aren't commonly inhabited. For example, an attic, maybe a basement, maybe a crawl space. All right, somebody's rewiring something. They're putting lights in the ceiling, and they're going up there, and the splices all look just like spaghetti. They're everywhere. They're exposed. You might even have wire nuts on them, or everybody's favorite, electrical tape. But really, those splices need to be in a junction box with a cover on it anywhere it's at, in the basement, in the attic, wherever. And the reason for that is if there's any arcing, sparks flying off, we want that all to be contained in a box so that we don't have the risk of a fire in that situation. So improper splices, they usually come in bunches. Like if you see a few in a house, you're going to see a bunch because the same guy did most of the work, right? Or gal. I don't want to discriminate based on gender there. So anybody can do that and do it the wrong way, but it's also a fairly simple fix, and it should be taken care of. So you have all the components of your branch wiring in a junction box. That can be at a switch, an outlet, just a junction, anything like that. All right. And along with that, number 7 is uncovered junction boxes. And this is where, okay, we got all the wires in a box. That's good, but we still need a cover. And so that's what, a 59-cent fix. Go to Lowe's, go to the hardware store, buy some covers, and put those on any boxes that you see. And they could be plastic, they could be metal. Either way, they need to be covered. Number 8, old or missing GFCIs. GFCIs, of course, is the breakers that trip on and off. They're required to be within 6 feet of water in like a kitchen or a bathroom. Modern codes for kitchens are actually, they have to be on every receptacle in the kitchen or connected to one anyhow. But this was brought about. The purpose of a GFCI stands for the ground fault circuit interrupter. And it's near water because if a plug gets wet, if your finger gets wet and you go to plug something in and there's water and it's not GFCI protected, you can get shocked or worse. All right. A GFCI, depending on which brand you have, is designed to click off in like 5 milliseconds click off immediately with a load difference of as little as 5 milliamps, which is created when you have water. And so that's a safety feature, and you've seen them in bathrooms. They became required in bathrooms in 1985 and in kitchens in 1987. And so if you have a home that's, even if it's older than that, this is a good safety upgrade. All right. Inspectors don't inspect to code, but it's good to know some of that, and it's good to upgrade even if it's not required. So I would encourage you, if you have a kitchen, you have those old outlets on the wall, they don't have any kind of test button or reset button on them, or a breaker that covers the whole circuit, you need to get that upgraded and increase the safety factor in your home. And then the last one I want to talk about, number 9, defective panels. And I don't have any here to hold up. They're probably too heavy to hold up anyhow. But there's a couple of name brands of panels that they're known as defective. They've had multiple problems with breakers coming loose, breakers not tripping when they should, not enough room in the raceways of the panels, improper connections, and so forth. One of those brands is Federal Pacific. Federal Pacific is probably the most commonly known brand that has defects. It's also known by the trade name Stadlock. So if you see either of those on your panel, if you're going to get your house inspected, you can probably be sure that's going to need to be replaced throughout the course of this transaction. If you just own your home now and you're not selling and you see this kind of panel, I would suggest having an electrician take a look at it. They're going to probably recommend you replace it. because you can't get parts easily for it anymore. And it's just an outdated product. They don't have this company originally was in millions of homes across the country. They got their UL rating fraudulently, and they went out of business through lawsuits in the 80s. And they never officially got recalled because the government committee that was assigned to study this somehow ran out of money. We didn't know the government ever ran out of money, right? But they did, and it never officially got recalled. So we still see them in a few houses, and you're definitely gonna change that if you have one of those in your house. Another kind of panel that has similar issues, it's not quite as regarded in such negative terms, is Zinsco, Z-I-N-C-O. And a unique thing about both of these panels is the Federal Pacific panel has red tips on the handles in most cases, and the Zinsco has various colors on the breaker handles in there. It could be green, blue, red. I think I've even seen pink. And so that doesn't make it bad, but it is a distinguishing feature of Zinsco. It has kind of the same issues as the Federal Pacific in that the breakers will become loose. They don't trip when they should. Another brand, and this one isn't distinguished by color, is Challenger. This is a little more hard to tell because you got to actually find the brand name on the panel, and they look like just your typical black breaker with the black handle. All right. And that one in some states is not insurable anymore, similar to Federal Pacific or Zinsco. And so, again, if you have that, contact an electrician, get his opinion on it, see what needs to be done about that. And finally, the fourth one on point number 9 is Pushmatic. Sometimes it's called Bulldog as well. And these are simply, instead of tripping the breaker, you're going to push it in to turn it on and push it in again and release it to disconnect it, so to speak. All right. And these were good panels for some years, but they're just outdated. You can't get parts for them anymore that I'm aware. And it's just an old technology. The breakers don't operate. It's hard to tell if they're on or off, which can be dangerous when you're trying to kill the power to a certain circuit. So just a thing it's like other things. When you have a home with a deck and it starts to deteriorate and fall apart, you've got to do maintenance on it or you have to replace it. With electrical panels, with electrical anything that we just talked about, there's just things in your home you have to replace over time. This is for your safety. It's for the safety of all the occupants. It's for the safety of the house itself. And so I would encourage you, go through these lists of 9, see what you have that you have questions about, you're concerned about. This is not to alarm you. It's just to inform you so you can take the steps you need to follow up and make your house as safe as possible. If you'd like us to come take a look at it, if you'd like to have an inspection so we can evaluate all these for you, feel free to call us here at Gold Key, and we'd be glad to do that for you. So thanks for watching, listening, everybody. Have a great day. Have a great week. Make the most of it, and be your best in all that you do.